Question 7. The diagram below shows the first 4 diagrams in a sequence of regular hexagons. Each regular hexagon is made using sticks of unit length. So we have diagram 1, 2, 3, and 4. Complete the diagram below to represent diagram 5 in the sequence of regular hexagons. So diagram 5, if you notice between diagrams, notice, for example, diagram 1, we have 1 above, 2 below, and so on. It increased by 1, 2 above, 3 below, and so on. So the top is increasing by 1, likewise the bottom. So the fifth diagram, notice diagram 4 have 1, 2, 3, 4, 5. So the fifth diagram should have 6 below and 5 above. So so we have 6 below, 1, 2, 3, 4, 5. So we want one more to complete the 6. So the shape should have 6 sides. So this one there. So something like that. That's the 6th one. And then we should have 5 above. So we need 3 more, right? So we can put one here. Can put one here also. So make sure each of them has 6 sides, and then we can put another one. So something like that. And of course yours should look way better than mine. Alright, next, the number of regular hexagons H. So hex H, the number of sticks S, and the perimeter of each figure should follow a pattern. And we can see the pattern here. Let's look at the pattern. So for the hexagons here, notice they are increasing by 2. The number of sticks increasing by 8, and the perimeter increasing by 4. So for the fifth one, for the fifth diagram, increasing by 2. So this should be 11. It's increasing by 8. So this should be 47. You see it increasing by 4. We already have the 28 there. Now we're asked to determine some missing values. Now let's look at the second column. Notice what is happening here between the diagram number and the number of hexagons. So the number is double than then we add 1. So the first value, so double 1, you add 1, you get 3. Double 2, you get 4, add 1, you get 5, and so on. Double 4, add 1, you get 9. Double 5, add 1, you get 11. So to get the 47, this would have to be 23. Double 23, you get 46, add 1, you get 7. In terms of the rule here is definitely 2 times n plus 1. Since you're increasing by 2, so notice the first column, the values are multiplied by 2 and the 1 added to get the values in the second column. The third column, values are increasing by 8. So obviously we'll begin with 8n. And then what do we add now? We add in 7. 8 times 1, that's 8 plus 1, 7. 8 times 2, 16. Add 7, you get 23. 8 times 3, 24. Add 7, you get 31. 8 times 5, 40. Add 7, you get. So it's 8n plus 7. And then this one, we are increasing by 4. So we'll begin with 4n. And if you notice 4 times 1, and of course you'll add 8 to get the 12. Just check if it's consistent throughout. 4 times 2, 8, add 8 to get 16. 4 times 3, 12. Add 8 to get 20. 4 times 5, 20. Add 8 to get 28. So these should be the rules that the patterns follow. So to get this missing value, will be 4 times 23. That's 92. Add 8, we get 100. So that should complete her table. Skylar says she can make one of these figures with a perimeter of exactly 1005. So the rule for the perimeter column is 4n plus 8. So the perimeter rule is 4n plus 8. And if you want a perimeter of 1005, replace p with 1005. Let's find out this diagram will give us that. So 4n plus 8. We can subtract 8 from both sides. So we're left with 1005 minus 8 equal to 4n. That's 997 equal to 4n. Divide both sides by 4. We end up with decimals. 249.25 or something like that. And of course, n cannot be a decimal. So this tells us that this is incorrect. Incorrect. And the reason, the diagram number cannot be a decimal, right? So the diagram number cannot be, or cannot have decimals. In other words, diagram number must be a counting number, a natural number. Alright, let's move on to question 8. The functions f and g are defined as follows, and we have f of x and we have g of x. We're asked to find g of 2. So to find g of 2, we simply go to the function g and replace x with 2. So g of 2 is 5 minus 2 squared. That's 5 minus 4, which is equal to 1. Next, we're asked to find f inverse 3. To find f inverse 3, we first need to find f inverse x. So to find f inverse x, we'll let y be equal to 2x, whatever the function f is, 2x minus 1 over 3. We can times both sides by 3, so we can times both sides by 3. So we're not with 3y, let's cancel that, equal to 2x minus 1. And of course, we can interchange x and y. So interchange x and y, finding the inverse of the function. Or we could have interchanged before we times both sides by 3. So let the x be y and the y be x. So this becomes 3x equal to 2y minus 1. And of course, now we solve for y. To solve for y, we can add 1 to both sides. So that cancel that. So we're left with 2y equal 3x plus 1. We'll divide both sides by 2. And whatever you have for y, that's your inverse function. So therefore, f inverse x is whatever you have for y, 3x plus 1 over 2. So which means that f inverse 3, replace x with 3, so that's 3 times 3 plus 1 over 2. 3 times 3, that's 9. 9 and 1, 10. 10 divided by 2, that's 5. So f inverse 3, that's positive 5. Part 2. Derive an expression in its simplest form for f g of x. So f g of x is f of, what was g of x? G of x was 5 minus x squared. So g of x, we're replacing that, is 5 minus x squared. So finding f g of x is same thing as finding f of 5 minus x squared. Now f, remember that f is 2x minus 1 over 3. So f is 2x minus 1 over 3. So f of x, let me repeat it here, is 2x minus 1 over 3. So f of this, we're going to replace the x with whatever is in the bracket. So replace x with whatever is in the bracket. And that's 5 minus x squared and then we have our minus 1 all over 3. We are asked to simplify, so we expand the bracket. 2 times 5, 10. 2 times minus x squared, that's minus 2x squared minus 1 over 3. And then if we group the constants, what we end up with is 10 minus 1, that's positive 9. And we have minus 2x squared all over 3. I think that's the best we can do with it. Part 2. Sketch the graph of a function g of x in the space provided below. On your sketch, indicate the maximum/minimum point and the roots of the function. Alright, so let's sketch the graph. So the g of, remember that g of x was 5 minus x squared. So let's find where the graph cuts the x-axis. That's the root. So we can let y be equal to 5 minus x squared. So we want to know where the graph cuts the y-axis. All right. So the graph cuts y-axis at whatever the constant is in the function, 5. So this graph will cut the y-axis at 5. So this is 0, 1, 2, 3, 4, 5. So the graph will cut the y-axis at 5. When x is 0, notice y is 5. The graph will cut the x-axis when y is 0. So when y is 0, what we have is 0 equal 5 minus x squared. Solving for x, we can group x squared over here. So we have x squared equal positive 5. So x equal to, by the way, plus or minus the square root of 5. So it's plus or minus the square root of 5, that's approximately 2.24. Plus or minus 2.24. So using this, so this is 1, this is 2, this is 3. So 2.24, so this is 1, this is 2. 2.24 would be somewhere about there, somewhere about there. Each still line would value 0.2. And the negative section would be, so this is negative 1, negative 2, negative 3, so negative 2.24. We have somewhere there. So that would be with the graph cuts the x-axis or the roots. So of course that would be your graph, right? And of course this would be the turning point. And of course it would be a maximum. Remember the turning point, for the turning point, the x coordinate is negative b over 2a. So if this is our function, notice there's no b value. So we have an a value, we have a c value, there's no x coefficient. So the b there is 0. Alright, so the x is equal to 0. And if you substitute 0 to get the corresponding y value, you substitute 0, what you'll have is 5 minus 0 squared, which is 5. So the turning point, x is 0, the y is 5, 0, 5. Same point as where the graph cuts the y-axis. Next, the graph below shows a quadratic function. There you have a function. And we're asked to, on the grid above, draw the tangent of the curve. Draw the tangent to the curve x equal 1. So the tangent is in a line that touches the curve only once. And we're asked now to use the tangent drawn to estimate the gradient of the curve at x equal to 1. Alright, so we're basically asked to draw a tangent and to find the gradient of that tangent line, which will also represent the gradient of the curve at x equal to 1. So let me just transfer this. Let me just use draw it in paint. Alright, so let me just transfer to paint screen. So the tangent would look at x equal to 1, that's here. when x equal to 1, so that's over here. So the tangent line would look something like this. You must touch the curve only once. So it should look something like that. Let me see if x equal to 1, so of course it's to touch the graph only once, right? So we just, as best as I can. Okay, so it should look something like that. Of course, you must touch the graph only once at x equal to 1. And then this line is a tangent line. We're also asked to find the gradient. So to find the gradient, we need 2 points on the line. So here we have that there. Just change the color. So here is a point on the line. This point is what? 1, 3. So 1, 3 is a point on the line. And another point on the line is this point. So notice the scale for the x-axis. So this is 1, so this would have to be 0.5 in the middle here. So it's going up by each block, we're going up by 0.25. So this point, well, it's 1, 3, you need another point that the line passes through. So here is when the y is 4, the x here, that would be 1.25. So 1.25. So this line passes through the coordinates 1.25, 4, 1 and 3. So it passes through 1.25, 4. Also passes through 1 and 3. We call this x1, x2, x1, y1, and x2, y2. So the gradient, y2 minus y1, that's 3 minus 4, over x2 minus x1, that's 1 minus, so that's negative 0.25. So calculate that, that's negative 1 divided by negative a quarter, that's positive, that's 4. So the gradient is 4, so y equal mx plus c. If I substitute 1, 3, the y would be 3, the m would be 4, the gradient, using this, x would be 1, so substituting 1, 3, right? 1 for the y, 1 for the x, 3 for the y. So plus c, so bring that over, so 3 minus 4 equal to c, so c is negative 1. So therefore the gradient is 4. Are we asked for the equation? Oh, the equation here. So the equation is y equal mx plus c. And we know m is 4, c is negative 1. So it's y equal to 4x for the 4 for the m, and c is negative 1. So question 9, that's circle geometry. 9 part A, that is. So we have circle and the shapes, some shapes inside. So we have vx, y, z, as we can see there. What else do we have? So the R-line is circumference, as we can see. Center at O, diameter is Vy. We have a tangent there at V, and we are given some angles. So state the theorem that justifies the values of each of the following angles. So we are told that angle B is 62. We're told that angle B is 62. Now, why is angle B 62? If you notice, angle B here and angle X here, they are in the what we call same segment. They are being extended, subtended from the same chord. Look, if you look at the chord ZV, from ZV, we have two lines there to converge at X. And from the same chord ZV, we have two lines to converge to form B. Alright, so there are angles, we'll call it angles in, we'll call it same segment. I could write out that these angles are formed from the same chord. Put slash, they're formed from the same chord, ZV. Next, angle C, why is it 124? So angle C, again, if you look at ZV, VZ, the angle formed at the circumference is 62. And the angle formed at the center should be twice that. So C is the angle formed at the center from the same chord, ZV. So from ZV and the circumference is 62. At the center where we have C, it should be double that, which is 62. So angle formed at the center is twice the angle formed at the circumference. So it's twice the angle formed at the circumference. Next, we're asked to explain why angle OV is 90. Angle OV, let's look at the shape again. Angle OV, here's OV. Notice OV is the radius, since O is at the center there, and V is a part of the tangent. That's angle between tangent and the radius is a right angle. So the theorem says angle between tangent and the radius is a right angle. A right angle is 90 degrees, right? Find the values of angle A, D, and E. Show all working where appropriate. So angle A, D, and E. Let's determine the values of these angles now. A, D, and E. A, D, and E. So angle A. So we can do one of several things. So angle A is in the alternate segment to 62. So angle A is alternate to this angle in this triangle, which is 62 degrees. Alright, so angle A should be 62 degrees. Another reason we could have given is that this angle C is 124. Alright, 124 degrees. And it's an isosceles triangle because Z to O and V to O represent the radius, and they are the same length. So these opposite angles, since it's an isosceles triangle, ZOV is isosceles since these opposite sides represent the radius. So the opposite angles are also equal, and they should be and all angles are to give 128. If you subtract 124, from 180, you'll be left with 56. So these two angles should have to give 56. So this should be 28 degrees. D should also be 28 degrees. By the way, so these 28 degrees. From that reasoning, we're also asked for that angle. And this is a right angle. So angle A would be 90 minus 28, which gives us 62. The other angle we're asked to determine was angle E, which can be easily determined. Angle E, we can look at it from several perspectives. I'll use a simple one. If you notice an angle E, notice YV or VY. That's the diameter. Now the diameter, the line subtended meets at Z there. So this should be a right angle. Should be a right angle here formed at Z. Alright? So this angle here at, or better yet, let's focus on triangle ZXV. ZXV. So we know all the angles in a triangle add to give 180. Alright? So if we add all the angles in that triangle, so the angle in this triangle, Z at X, that will be 62. The angle at this, at V there, will be 28 and the 18. That's 46. Plus, these two angles, D and E, should complete the 180. So that's 28 plus E, and all of that should equal to 180. So if we add up all these values, 62, 46, 28, we end up with 136 plus E equal 180. And if we subtract 136 on both sides, we're left with E being equal to, that's 44 degrees. So this angle should be 44 degrees. The diagram below shows a quadrilateral PQRS formed by joining two triangles. Alright, we can see two triangles here. Calculate the length of QR. So QR, triangle here, we can use the cosine rule. So let's use the cosine rule. So we take the opposite side here to the angle. That's QR. So QR square. So QR square equal the other two sides square, which is 16 square plus 18 square minus 2 times these very same sides. So minus 2 times 16 times 18. Cos the angle opposite to the QR, that's 25. And we can enter these as they are in our calculator. Everything one time. We end up with 57.97. So QR would be the square root of that. So since QR square is equal to that, QR is the square root of 57.97, which is 7.61 meters. So QR, that's 7.61 meters. Next, we're asked to find the bearing of P. We are told the bearing of P from S is 205. Determine the bearing of R from S. So the bearing of P from S is 205. So the bearing of P from S. The bearing of P from S. So we're coming from S. So coming from S, north of S. So all of this we are told is 205. So we are asked to find now the bearing of R from S. So the bearing of R from S, bearing of R from S would be from the north of S. So what we want is this angle. Now the entire angle is 205. So the answer to this question, the bearing of R from S, this angle, called theta, would be 205 minus the 72 minus the 25, and that should give us 108 degrees. So this angle should be 108 degrees. The bearing of R from S. From S means from the north of S. We're also asked to find, so this is 108. We're also asked to find the bearing of S from P. So the bearing of S from P, so coming from P, so we're coming from P, we're coming from the north of P. From the north of P. So what I want is this angle. This angle. Let me call this angle X. And then of course, these two north lines are parallel. So this angle, let me call this angle Y. These two angles, X plus Y, must add to give 180 interior angles, since these are formed from the same north pole, connecting the north poles there. So these two angles should add to give 180. Angle X and angle Y. Alright? Now, angle Y can be calculated easily. So the total revolution is 360. So we know 108, 25, 72. So angle Y here, let's work with angle Y. Angle Y here will be 360 minus the minus the 205, because all of here, from here to here, we know already is 205. All of that is 205. So 360 minus 205, and that gives us 155. So this angle at Y here is 155 degrees. And the 155 plus the X, so X plus the Y, which is 155, must add to give 180. So if we subtract 155 from both sides, then X is 25 degrees. So this angle is 25 degrees. So the bearing of S from P is 25 degrees. Let's move on to our final question. The determinant of the matrix is 24, so the determinant, cross multiply and subtract. So the determinant is 24, so the determinant is 24. Cross multiply, we get negative 6v minus, sub multiply, minus negative 10v. But the double negative, we're not with plus 10v, and that should be equal to 24, we are told. So negative 6 plus 10, that's positive 4. So 4v equal to 24. Divide both sides by 4. So v is equal to 6. L is 9532. M is 2, negative 4. Find LM. So LM, row by column. So 95 times 2, negative 4. So it's 9 times 2. So 9 times 2 give us 18. And 5 times negative 4 is negative 20. And then the bottom row now, for 3, 2, do the same thing. So 3 times 2, that's 6. And 2 times minus 4, that's minus 8. So this is actually 18 take away 20, that's minus 2. 6 take away 8, minus 2 again. L inverse, the inverse of L. Now L, what was L again? L was 9532. So L was, let's restate L. L was 9532. So the L inverse is the 1 over the determinant of L times the adjoint of L. So it's 1 over the determinant, the cross multiply and subtract. So 2 times 9, 18. 3 times 5, 15, right? The adjoint, the first diagonal, we switch the values. So 9 and 2, we swap these values. And then the other two values, we change signs. So minus 5, minus 3. So that's 1/3 into 2 minus 5 minus 3, 9. And we can go even further by multiplying each term in the matrix by 1/3. So 1/3 of 2, that's 2/3. 1/3 of negative 3, that's negative 1. 1/3 of negative 5, that's negative 5/3. 1/3 of 9, that's positive 3. Next, PQ, the vector PQ is 5, negative 4. If the point P is negative 2, 3, determine the coordinates of Q. I'm going to call the coordinates of Q xy. Let me call the coordinates of Q xy. So we know the vector PQ is equal to, we just reverse subtract Q minus P. So PQ, we know is 5, negative 4. Q, we don't know Q, let's call it xy. And P is 5, negative 4. No, P is negative 2, 3. So P is actually negative 2, 3. So it's xy we want to find, right? So we can just group, so we bring this over, it become plus. So xy, leave this on the right hand side. So we have 5, negative 4. Bring this over, it's now plus. In the bracket we have negative 2, 3. So we add these, 5 plus negative 2, that's 3. Negative 4 plus 3, that's well, xy. 5 and negative 2, that's positive 3. Negative 4 and 3, that's negative 1. So the coordinates of Q are, for the x, it's positive 3. And for the y, it's negative 1. In the pentagon, OABC, as we can see there, OA is parallel to DC and AB is parallel to OD. We're also told that OD is 2 times AB. So AB is B. So OD is 2 times that. So OD will be 2B. OA is A. Where we're told that DC. So OA is 2 times DC. So A is double DC. So if OA is A, then DC is half of that. So DC is actually half A. So OA double DC, which means DC is half of OA. Finding in terms of A and B in its simplest form, AD. Now to get AD, to get the effect of AD, A to D, that's from here to here, A to D, we can go OA to O and then O to D. So AD, that's A to O and then O to D. So A to O, now O to A is A. But since direction change, the sign will also change. So that's negative A. And OD, same sign, same direction. So it's 2B. Next, we're asked to find the vector BC. So BC is the next vector we have to find, BC. If we're at B and you want to get to C, so BC. B to C, that's here. So BC, we can go B to A. And then A to D. And then D to C. That's how we can get from B to C. Alright, so B to A. No, B to A. So A to B is B. So its direction change, sign change. So B to A will be negative B. Alright, B to A will be negative B. And now A to D. Now we just found AD to be negative A plus 2B. So that's negative A plus 2B. And then B to C, D to C, we know D to C is half A. So we group the like terms now. We group the A's. So group the A, we have negative A, negative 1A plus half A. So negative 1 plus half, that's negative half. So this is negative half A. And we're grouping the B's. This is negative B, negative 1B plus 2B. That's actually 1B, so that's B. So that's negative half A plus B. And then BC, well, that's BC we just found, all right? That's BC we just found, all right? Negative half A plus B. I just keep it up there so we can look at a diagram while we're doing it. And then the final question, state the conclusion about AD and BC that can be drawn from your responses. So if we compare AD to BC, let's compare AD to BC. Here is AD. No, that's not AD. That's BC. Here is AD. Here is AD. And here is BC. And if you look at the comparison, if you compare these two, notice that 2 times BC would give you AD. You notice that? 2 times BC, 2 times the vector BC will give you the vector AD. So 2 times BC, here's BC. If you multiply BC by 2, 2 times negative half A, that's negative A. And 2 times B, 2B. So 2 times BC, you'll end up with AD. So conclusion about BC and AD is that, and by the way, this is talking about the length or the modulus. Alright, so BC, or you could say AD is twice the length of BC. Or you could say AD is parallel to BC. As we can see there, so compare AD and BC. Notice 2 times BC give you AD. So that's it.